the whole interview is being recorded now. Yeah.
Right. So, good evening, gentlemen.
All right.
So I was quite happy to receive your email on the request, and it's my pleasure to help you out with your queries. Okay. So okay, I introduce myself first. My name is my full name is Divakaran Balan. So I'm local in Kluang, and with this company, Sintoma Malaysia Sinambat, which we're going to discuss today, I've been with the company for past 32 years. Okay, 32 years, and 9 years of the 32 years I was in Vietnam, doing same thing, operations management. And the Vietnam plant is similar to our Kluang-based plant, which produces polymer dispersions. Okay, and so yeah, and currently I'm based in Kluang, and looking after product and manufacturing. So it's part of the operation also, but specific to product and manufacturing. So okay, I pass to you.
All right. Thank you, sir. So I'm gonna introduce ourselves now. But first, good evening, Sir Divakaran. Thank you so much for setting aside your time to join us today. And we really, really appreciate the opportunity to speak with you. Now, my name is Luah Shirong. You can call me Shirong, and I will be the host for this interview session. And I am pleased to introduce my team members who are joining us today. We have Daniel Kaujunja, Daineswaran, and Yap Chong Lee. Now,
Yeah, hi. Hello to everyone.
All right. Thank you, sir. So now we're going to begin by asking the first part of the question, fundamentals and materials. Now, first, what is a polymer dispersion and how is it different from standard solid plastics? And second question is, how do you ensure that the raw materials from your suppliers are always of consistent quality?
Okay, to answer that, okay, part one, fundamentals, materials. So we talk about polymer dispersion and conventional plastics. Okay, conventional plastic normally is more robust and is more harder compared to polymer dispersion. Polymer dispersion normally will be in liquid form. Okay, so I'm not expert about the conventional plastic because I'm not in that industry, but chemistry wise, it's similar. Okay, chemistry wise, the main raw materials they use for conventional plastic and also polymer dispersions are monomers. So only thing is they make polymer dispersion as liquid, and conventional plastic they make it into pellet forms, normally in pellet forms, bits and pellets. And polymer dispersion main end users are in coatings. Okay, normally in coatings, coatings for paint industry and construction, your cement work, your sealant, okay, and also adhesives, adhesive like bonding agent. So this will use polymer dispersions and also some very soft plastic linings. So this where the polymer dispersion is related to plastic. Plastic lining like the insulation for electrical cables, all, and the PPF. So that uses polymer dispersion. So, and the other hand, for conventional plastic, normally you can see everywhere, conventional plastic is molded, molded end products like bottles, like housings, like the TV housing, everything lah. On your car, you can see the dashboard. So, but the dashboard, you see, is molded plastic. So it's conventional plastic, and they give you a layer, a layer to make it beautiful or make it nice. That is polymer dispersion, that layer. So this is the difference between polymer dispersion and conventional plastic. So by right, it should be totally two different types of product. Okay, should be two different types of product, and one is liquid based, another one is solid. So these are the difference. Did I answer that question?
Yeah. Thank you
Okay.
for explaining that, sir. We really appreciate that level of detail.
Okay.
So now
The second one about raw materials. Okay, raw material from supplier, because the company is producing in big scale. So normally we don't just keep one supplier. So for any raw material, there will be like 2 or 3 suppliers. So, but the requirement is any raw material coming into the site. Okay, all the raw material coming in the site, they will have the quality assurance and to our requirement. So normally the parameters differs, like solid content, viscosity, pH. For each raw materials are different. So, and we are not handling this locally, or we have a regulatory department in the HQ. So they control all these raw material parameters globally. So if you talk about Syntoma, Syntoma is a global company, we are in many countries. We are in Europe, we are in US, we are in Middle East, and also Asia. So it's everywhere. So we need somebody to take care of these raw material parameters and legal thing of the raw material. Some raw material can be illegal. So that's why they are very strict in this. So they have a regulatory department to handle this. But locally, each time any raw material comes, whether from supplier A or supplier B or supplier C, it will follow our requirement, and which is stated on the supplier quality assurance lah. It will come with a paper, say this raw material today they are delivering meets these parameters. So some of it we will test. We will take sample and we will test. So this how we control that turnaround incoming raw materials. Okay. And alternately, we will do like random checks on the bulk storage, because main ingredients for polymer dispersion is monomers. Okay, the monomers will come in liquid form in a barrel, road tankers. Road tankers, and we will unload into storage tank, big storage tank. The capacity is like 500 meter cube, 300 meter cube. So it always won't be empty. So we need to top up. Each monomers, it will come like twice a week, we top up. And each time they unload, we will take sample, we send to the quality control, we do the testing, they pass, then only we unload to the storage tank. Okay, this is very crucial because you're going to mix this monomer with the earlier monomer. So we cannot just simply mix. Okay, so this kind of raw material control that we have on site. Consistent wise, as I said, it will follow our requirement. So we need, normally the requirement is a range lah. We cannot say I want total solid content just to be 50. Cannot. It's very difficult for the supplier to produce. So we will give them a range. This parameter solid content, I want it to be like 50 to 52. We got 2% advantage. You know, it can be plus minus lah. It's 2%.
So there will be tolerance.
Yes, correct. There's tolerance. Right.
Mhm.
Every parameters there's tolerance. Okay, including color. Like some liquid we need color, but normally we give like 5 max. You know, it can be 4, it can be 3, but 5 is the max. So it's like that. So they have to meet. So every time any incoming which meets this raw material specification, we accept. So that's how we maintain the consistency of the incoming raw material.
Mhm.
Okay.
All right, thank you, sir. That was a very good and that was a very clear clarification of the whole process, and it helps us understand the differences that we just asked. So
You
now,
can you can
Mhm.
add on. I understand the question is already draft, but you can
Mhm.
from time to time you can add on. No? If
All right.
anything that you want to ask, feel free to ask.
Okay. Thank you, sir. We will give you additional questions if you have them.
Yeah, sure.
So moving on to part two, which is the manufacturing process and machinery. Now, question three is that can you walk us through the main steps of how you produce all these dispersions?
Okay,
And for question four and five, I'm going to pass it to my pal, Darina Sharon.
okay. So let me start with the question 3 first. For that, I think because if I just give you explanation, you can't imagine, you know, how the process looks like. So I'm not sure whether I can share. I have a simple diagram. Just give me a minute, please.
It's okay, sir. Take your time.
Can you see my screen? Can you see the screen?
Wait, sir. We don't see anything yet.
Wait, Can you see that? No, also.
No.
Wait, So while I'm opening this, why I cannot share? Okay,
Okay, we can see it now.
you can see.
Mm-hmm.
Okay, what was the question just now? It's about manufacturing, right?
All
Facilities.
right. Do I repeat the question, sir?
Okay, it's okay. I think it's about this lah. So I walk you through the manufacturing process. So basically in Kluang manufacturing plant, uh, we have three manufacturing plants in Kluang site. Okay, because this Sintoma, they're not only having dispersion business, they also have polymer elastomers business, which is synthetic latex. You know, so in Keluang, basically we have one synthetic latex manufacturing plant and one polymer dispersion plant, and the other one is alkyd resin manufacturing plant. So you have three manufacturing plant in Keluang site, and these two plants, which is polymer dispersion and alkyd plant, alkyd resin, is under CCS division, which is coating construction solution, which is basically the polymer dispersion lah. And the other plant, which is the synthetic latex, we call it HPPM. It's a different division in the Sintoma. Okay, Sintoma have three different divisions. One is CCS, okay, which is we are discussing today, polymer dispersion and alkyd resins. That is CCS. And the other one is HPPM, which is synthetic latex. They produce SBR latex. And the other one is adhesives. Adhesive, like bonding agent, everything is different. So three different division in Sintoma polymer business. So when talk about Keluang manufacturing site, polymer dispersion. So in polymer dispersion plant, the plant operates 24/7. Okay, 7 days a week, 24 hours. And we have 4 crew members. So we have 4 crews lah. And each crew will have 3 people who will work 12-hour shift. So 12-hour day shift and 12-hour night shift. And the process plant will be running 24 hours, 7 days a week, unless we got like preventive maintenance shutdown and inspection. We only shut down during that time. Other than that, all will be running. So this process plant, polymer dispersion Kluang, we have 5 reactors. You can see here, okay, 5 reactors. Okay, reactors is the main equipment to polymerize the polymer dispersion. We call them reactors. So, and the other 5 coolers and 2 secondary coolers is supporting tanks for the reactors. They mean when you end the process in the reactor, you transfer to cooler to cool down, and add in some other raw materials before we can filter and move to storage. Okay, these 5 reactors, we call them with alphabets from C to G. Okay, so you can see RE is reactor E, RF is reactor F. Okay, and here is reactor G, this is reactor C, and reactor D. Okay, so it's from C to G. Uh, why is C to G is because we used to have A and B, a very small reactor at different location in Kluang, but there's no more. It's already decommissioned, there's no more. So that's why the remaining is C to G, 5 reactors. Okay, so far okay? Am I clear?
Very detailed.
Okay, so here reactor C, if you see the volume on your right, okay, on the right side of the screen, if you see reactor C, reactor volume is 3.6 meter cube. So it's not big, it's a small reactor, 3,600 kg lah, about that. One time, each time you process each batch. So typical batch is 3 metric ton, we call it. So normally this is the reactor volume, but the batch we produce normally lesser than the reactor volume. Should be, if not it will overflow. So normally that formulation recipe given for each product is lesser than the reactor volume. And this is the cycle time per batch. So given here is typical cycle time. It can vary by product. Some product can take only 7 hours to produce, and some will go to 10 hours in this reactor C. And the product grade here means the product chemistry is adhesives lah. So adhesive is like bonding agent. You know, the glue, the woodwork, all these are adhesives. So this reactor, we only produce this type of product. And then you go to reactor D is 6.3 meter cube, and each batch like 5 metric ton. And this is the cycle time, 9 to 12 hours. And acrylics, the great product we produce is acrylics. So we have, by chemistry, we have like 3 different types of products. One is acrylics, one is vinyl acetate, one is adhesive. So we have different types of chemistry. And if you see VA copolymer means you use multiple monomers in this product. Normally acrylics is like a mixture of styrene monomer and butyl acrylate. If you see VA here, like the E, VA is vinyl acetate, is VAM, vinyl acetate, very violet monomer. Okay, and reactor F, reactor G. So this reactor F, E, and G, the reactor size is similar. And typically the product we produce like 12 metric ton, and that cycle time for each batch is 9 to 12 hours. And in fact, we got until 15 hours also. Okay. So this is the maximum design temperature of the reactor lah. So normally polymer dispersion, the highest temperature will be around 90 degrees C during process. Okay, we are not talking about initial, not talking about ending. So because normally initial it will be lower temperature because it's just water, and the ending will be cool down. So process temperature, I'm talking about 90 degree, the highest, and the lowest will be around 70 plus. So this is the range of the temperature. And all this reactor, the material, shell is inside. This reactor are designed jacketed. So you have water running around it. So we call it jacketed because the heating and cooling is done by injecting water. When you cool, you inject normal water. When you heat, you inject steam into that water to bring up the temperature. So the shell is internal of that, where you have the mixer. The material is stainless steel 304. Okay, and the jacket, the outer layer will be carbon steel, mild steel. So because we just use water inside that, so that is cheaper design lah. So inside is stainless steel, outside is mild steel. All the reactor. So here if you see heating and cooling, hot water used as heating medium, but actually it's not hot water. It's actually water. We inject it with live steam, so it become hot water. Okay, and then cooling water used as cooling medium, and this is not cooling water, it's just normal water, around 28 to 30, 31 degrees Celsius temperature. So that we use to cool down the reactor. Okay, and cooling medium which are circulated via the external jacket of reactors. So you have pumps which bring in the cold water, normal water into the reactor jacket. You will circulate and you will go out back to the cooling tower. So that's how it flows lah. And steam is same. Once you inject to the water, it will go to the jacket, it will heat up, and these reactors are controlled by DCS. Okay, each batch is controlled by DCS, whereby individual grades products we already preset what is the temperature required, what is the duration required. All these are already preset inside. So each time the technician, he just need to download what product he want to run, and he download the recipe, and the DCS will do its work. And the technician just need to monitor each batch. Okay, this storage volume is for finished products. Okay, total we have 35 tanks, and the size range varies from as small as 10 metric ton up to 60 metric ton. In total, we have 35 units. And this is the plant capacity overall for the year. Is 32,000. If you run full swing the whole year without any breakdown, you can get 32,000 metric ton. Okay, we go into the process. As I said, all the 5 reactors just now, okay, all the 5 reactors will have a similar process flow like this. Okay, we'll have a similar process flow like this. Okay, if you look at this from the left, monomer bulk tanks. So these are the monomers. Okay, monomers will have separate storage tanks, and then when required, the type of monomer, as I said just now, the technician will download what product he want to make. We already have a schedule every day, so he will download that product recipe into the DCS. Okay, after that, this flow will start moving. Okay, the monomers will charge into here MWT. MWT is monomer weighing tank. At a batch start, the monomer will transfer from storage tank into MWT, monomer weighing tank, and partially from monomer weighing tank, about 5% to 10%, it will transfer into initial monomer tank. So what is initial monomer is, during the reactor start polymerization, exothermic reaction, we call it. When the reactor want to start polymerization, it needs some monomer to react with the initiator, with the catalyst. So we have monomers, we have surfactant here, and we have initiator catalyst. So normally these catalysts come in powder form. So we will add it direct to the reactor through this hopper. So we charge in the initial 5% of the total monomer. Normally the total monomer around 5 to 6 ton, metric ton. The batch is 12 metric ton. So your 5 to 6 metric ton will be monomer, and maybe 3, 4 metric ton will be water. Water is the main raw material for, apart from monomer, water is another main raw material for polymer dispersion. So you must have water, you must have monomer, you must have surfactant, stabilizers, and you must have initiators, catalysts. So you mix all these, only it will become polymer dispersion. So the monomer will be emulsified in the water with surfactant added, and then the initiator in powder form we will direct to the hopper to start the reaction. So once the monomer meet this initiator catalyst, and it will start to react, and the temperature will rise. So that's how we start every reaction. Every batch is similar, even though different products, but the process flow will be similar. Only different ingredients. Some products use different raw material. Some products use different raw material. Okay, one the reactor process here, and here SWT is solvent weighing tank. This is a surfactant solution tank where we transfer the raw material. Some need to pre-dilute, some need to pump direct. We keep in this small tank up here. Okay, and this, when the reactor already download, it will discharge whatever we need from this tank. This surfactant solution tank, you have like 16 units. So different tanks, different materials. So whatever we need, it will charge to this SWT, solvent weighing tank, or surfactant weighing tank. The quantity, how much we need, it will charge here. Same, MWT will charge to IMT, how much quantity we need. And this SPT here is normally for colloid PVA solution preparation. So, but PVA solution is just for certain products. It's for vinyl acetate products. For acrylic products, there's no PVA solution. We just use water. So water we use is deionized water lah. Here, deionized water. So when all these raw materials, it will go into reactor according to timing. So our process is batch process. In Kluang is batch process. So we will start individual batches. So every 9 to 12 hours, we start a new batch. We start a new batch. So the process, the flow will repeat. So after the reactor process for 9 to 12 hours, the product will transfer to cooling tank. You see, beside is cooling tank. So this is, the cooler is just a holding tank before you go to storage tank. Because in between, from cooler to storage tank, you will do the filtration. And the reactor, I forgot about this. The reactor is, we have delay phase, delay in phase. So what delay phase is? To convert the monomer and the surfactant into polymers, you will need a constant addition of monomer and surfactant and also catalyst. So normally the delay phase, we call it delay phase, where we continuously add monomer from MWT, we add catalyst from SWT into reactor, is 4 to 6 hours by product. So in these 4 to 6 hours, there will be continuous addition of monomer into reactor, continuous addition of catalyst into reactor, and sometimes addition of surfactant. It will convert the monomer and the surfactants into polymers slowly during that 9 to 12 hours time. So after that 12 hours, batch will be transferred to cooler, and from cooler we do filtration into the bulk storage. Okay, so far clear about the
Very
process?
clear. Mm-hmm.
So this some pictures lah I want to show you actually. So look alive a bit when I show some pictures. So this is the SPT just now I'm talking about. You know the SPT here? This SPT, sorry, this SPT2 here. So these are this. Okay. These are pre-weighing, we call it pre-weighing, whereby the raw material comes in big packaging. So, but each batch using small amount of raw material. So we have to pre-weigh. That means we have to weigh out 2 kilo. So that is done manually lah. So that's what we put here, pre-weigh. Okay, and this is the SST just now I told you. And the far right, holding tank. The holding tank is SST. On the diagram just now, SST, you have about 16 unit. Okay, and some of the initiators just now I tell you to put in the reactor chemical hopper is like this. We have to weigh out solid chemicals. So this one, operator have to weigh out manually. And then the technician has to reactor. You see the one is the reactor. It's one of the reactor. We have 5. This is one of the reactor. Okay, and this is the weigh tank. This is the weigh tank. And this is the monomer storage on the on bottom here, monomer tank. Okay, these are partially, not all. Some monomer storage are on your right here. These are the big tanks. On the left, far left, this is a smaller tank of 20 metric ton. And the right one is like 300 and 500 metric ton. Okay. And this is the cooler. So this cooler tank is not a process vessel. It's just a holding vessel. Okay, and then this is the filtration we do lah. After the cooling tank, before going to the storage tank, on your far right is the storage tank. So we have to do a filtration in the middle here. And we do filter and we transfer the product into the storage tank. And then before we use a filter, okay, this is a filter on your right, right bottom, GAF filter. We put filter bags inside this. So the filter bag have different sizes for 40 mesh, 80 mesh, 150 mesh. This depends on the quality testing. Okay, they will advise how bad is because this finished product emulsion, they will normally have grit inside, some unreacted chemicals. Okay, so these unreacted chemicals we have to filter out before we do the packaging. So the packaging will be in these drums. This is 1 ton, 1000 kg containers lah. We call it IBC containers, and we also have the far left is the road tanker. So normally going to overseas one will go in IBC or drum. Okay, the local one mainly for coatings they will go in road tanker. Okay, did I answer your question 3?
Yep, you definitely did, sir. The whole process is so long and continuous, but you somehow explain it in a very structured and you made it very interesting. So now we're going to move on with the next question, question 4 and question 5. But for these questions, I'm going to pass it to my pal,
ask two questions. The first question is, what is the biggest challenge when moving a new product from the lab to mass production? And what is specific test must a batch pass before it is allowed to be sent to customers?
Okay, I think you have the miss out question 4. Most critical piece of machinery. From what I explained to you just now, so the most critical piece of machinery will be the reactors itself. Okay, without the reactor, there's no business.
Mm.
So, the simple way to answer that question, the reactors are the most critical lah. Of course, I mean for the reactor to process well, you have to have good maintenance, good schedule, and so on. But according to your question, I will say the most critical machinery is the reactor itself. Okay, and question 5 you were asking is what is the biggest challenge? Okay, new product. Okay, new product. Another, yeah, definitely, as you say, it's a very big challenge lah. Because until now, we still have issues when moving new products. Because this is a global company, so normally the new product is not newly developed product only. The new product in Kluang can be already produced in other site before this. So when it comes to Kluang, it will be new to us. So just because the setup, the reactor setup might be slightly different. So we will have issues with like cooling efficiency, heating efficiency, heat removal. Uh, this polymer production is an exothermic reaction. So it will remove heat from the process unit. So we have mixer. Every reactor have a mixer, and it will remove heat from the product. So that is called exothermic reaction. And if compared to resin production, resin endothermic reaction, it will absorb heat because resin produced at very high temperature, 280 degrees Celsius. So very, very hot. Polymer dispersions are, as I told you just now, like 70 to 90 degrees C. So the challenge every time we move, those days very difficult. But now, the company have did a lot of improvement, and we have a separate team of engineers, chemical engineers, and they are in charge of OIT team. So OIT stands for Operational Improvement Team. So whoever there in OIT team are chemical engineers. So what they will do, each time a product is going to be transferred or new product from R&D, they will do the trial themselves. So not only the technician, but the engineers will run that product and they will collect all the data. So basically polymer dispersion, what data they're going to collect is the temperature and the dosing in of chemicals, and the mixing time, mixing speed, very critical. This mixing speed also for polymer dispersion, because every hour when you mix the product, the viscosity of the product will increase. So it's important to study. If you fine tune it to the exact speed that you need, you will get a good product. So yes, a lot of challenges, but it's OIT team, they're doing the improvement and also they do the operation improvement. So OIT team is divided into two lah. One is process improvement, one is operation improvement. So process improvement, they will fine tune all the required during the process. And operation improvement team, they will fine tune all the operational things like the equipment, like the cooling, heating. So all this under operation. So that's how we handle a new product. But sometimes you are very lucky. New product, just one trial can go ahead. But most of the time, not like that. So each product, it might fail first attempt, second attempt, maybe on the third attempt only will pass. And then what we do is we need to have at least constant 5 batches pass. If a new product come, we need constant 5 batches pass, then we will commission the batch. So that's how we do it. So these are the challenges, okay, because of environment. The product might be made in UK last time during winter, so different weather and compared to Malaysia. So because polymer dispersions are liquid form, so temperature will affect, you know. Last time we had a factory in Guangzhou, China. You know, all the piping will be solid hard during winter. So these are the challenges lah when you transfer new product. If you develop a new product here in Malaysia, then you run, wouldn't be much problem. But Synthomer product mainly all coming from external, from UK, from US. So the difference in weather, all these are affect. Okay. Okay. Or anything else?
Yeah, that's good enough.
All right, thank you, sir.
I know I'm not being very clear, but you all can ask, you know, if you don't get what I'm telling. I worry that I mixed up everything. So you can ask.
All right, sir.
If not, you can just go ahead.
All right. So now I'll go to the question about quality, safety, and environment. So the first question will be, what are the most common safety hazards your team watches out for daily? And the second question will be, how do you prevent any sparks during the high speed mixing process? And the third question will be what safety system is used to stop the reactor from overpressuring if there's a power failure.
Yeah. Okay. I think I will cover all the question in one go lah. Okay. So the first one, what specific the test, like I mentioned, for our polymer dispersion, very straightforward. Okay, you only require total solid content, pH, viscosity, and this viscosity you have various type of viscosity lah. Okay, you have we call it Brookfield viscosity, you have Stormer viscosity, you have Gardner viscosity. There's so many viscosity, and apart from that, you will test grit content. Grit content is the one I mentioned just now, unreacted particles during the process. That is said to be grit content. Okay, and then some other testing which is required by customer. Okay, customers normally they have their own requirement. So the one I told you just now is the normal parameters that we put in our quality assurance. So each product going to customer, we will give quality assurance, supplier quality assurance, SQA. Okay, so in the SQA, these are the parameters are normally locked, which is total tolic content, pH, viscosity, clarity, okay, and grit content. And additional, some customers they want color. So it depends on the customer. We have the requirement, and they know who's the customer ask for color, and they will put color also. And some of that parameters with details monitoring, we will send it to our R&D. We have Asia Innovation Center in Kulai, Johor. So all these specific testing, okay, all these specific kind of requirements, you have to send samples to Kulai. They will conduct the testing and they will produce the report. So that's more special lah. But normal delivery quality, only this. Solid content, pH, viscosity, clarity, weak content, that's it. And if for coating industry, for paint industry, our customer are like Nippon Paint, Akzo Nobel, Jordan. So they need rundown film, rundown film, whereby you pour a certain amount of emulsion on a glass plate, and then you let it to dry, and you see the formation of grids and the clarity of the film. So coating industry, very important is that film, because they are doing paint, so they're very particular in that. So okay, that will answer your question 6. Okay, safety hazard, common safety hazard, watches out daily. Okay, as a process plant lah, okay, every day also is critical, okay, because we are doing process, and normal process hazard that we always want to avoid is a runaway reaction in the reactor. If you know runaway reaction where runaway reaction whereby you can't control the process any longer. So if you mischarge raw material, you will have runaway reaction. Okay, if the temperature goes beyond 100, you will have runaway reaction. Okay, why the temperature go beyond 100? Because your cooling system fail. Suddenly, all your cooling tower break down, or your cooling pump never transfer water, so the temperature can go up. Okay, so this I think will happen. So common safety hazard lah, apart from runaway reaction, we also have like loss of containment. Okay, monomer loss of containment, when you, because monomers you charge from bigger tanks into smaller process tanks. So you need to, although DCS is doing the job, but automated system can fail. Do you agree? Automated system can fail. Okay, it poor maintenance or the equipment itself fail, it can fail. So we worry about LOC. So that one we call it major accident event lah. So when you charge from bigger storage tank into smaller tank, you get LOCs. Okay, apart from runaway reaction. So these are the major hazards that we will try to avoid, and we already implement so many mitigations. I call it mitigations lah. So to stop the events from happening. Okay. The second one is prevent static. Okay, this because we are considered our process in zone 1. Okay, you know about zone 0, zone 1, zone 2. If you know about zone zone is where distance for hazards that can occur in a plant. Normally chemical plants has this zoning. They will call it zone 0. Zone 0 means is inside the process tank. So that is zone 0. So whatever precaution need to take for zone 0, you have to do. If they say no hot work in zone 0, then you cannot do hot work in zone 0. So zone 1 is like 1-2 meters away from the tank, the distance. That is called zone 1. So all our process reactors, okay, even the coolers beside, is considered in zone 1. So when it is located in zone 1, what we do is any equipment that we buy to install to that process vessel must be EX type, explosion type. Huh? Do you get? So EX type equipment are very expensive, and if you put EX type equipment, you won't get these static issues. Okay, and then grounding. So the vessels are grounded. You must have earthing. So all these are important. But mainly, whatever equipment you install on your process reactors, process vessel must be EX type, explosion type. Okay, that's how we avoid static lah. So our reactors, the agitators, the big reactors are with hydraulic motors. So hydraulic motor is not electrical motor. It run by hydraulic pump. Okay, and then two smaller reactor with EX type electrical motors. Okay, that's how we avoid static. Any equipment in the process building must be EX type. Even the technician using torchlight are EX type. They cannot simply use normal torchlight because the monomer vapors are everywhere in the process vessel. So each time the reactors are empty, the vapors are still there. So it can catch fire. So we limit even any work in the process building, any work in the plant itself, it goes through a permit to work system. So when we issue permit to work, we need to see what is happening to the process, in what stage, and did we did any good cleaning before we give to the contractor to work. So all this are taken care of. So that's how we eliminate the static issue all by installing all EX equipment. Okay. And safety system stop reactor from overpressure. Okay, reactor overpressure, very simple. All the process vessel, it might happen overpressure, right? It might happen. So suddenly when the temperature goes up, the pressure also will increase. What we have on each process vessel is the emergency relief venting system. So emergency relief venting system is a pipe. The pipe normally is calculated. The design is calculated by a competent engineer who can calculate on the sizing. The calculation is based on like how quick you can relieve the content from the reactor to avoid the reactor from exploding. So this it will relieve through the emergency system to a collecting tank. We call it catch pots. Okay, each reactor has its own catch pots, and this emergency vent system installed with a bursting disc, rupture disc. So that rupture disc is pressure rated. So some are 30 psi and some are 24 psi. So it's like 1 bar plus lah. So any pressure goes beyond that, it will break the rupture disc. And if the product want to release, it will release safely into a catch tank. So it won't release to the environment, or it won't release to the people nearby. And it won't make the reactor to explode. So overpressure, that's what we have for overpressure. Okay, relief, emergency relief system. So we have a emergency venting with a catch pot. Catch pot, or you can call it dump tank. So the dump tank is calculated to accommodate the full batch. If this is a 3 metric ton reactor, so the dump tank is double the size. So it's calculated, all are calculated. So that's what we have for emergency system. And also short stop. let's say a violent temperature, a violent reaction is happening. So normally we dose in a raw material. Normally is like MEHQ. It's a short stop to kill the reaction. Okay, we dose into the process vessel. Okay.
Right, thank you, sir. That's a clear
Yeah.
explanation about it. So I'll now pass to Yap Chong Lee.
Hi, Sir Divakaran.
Yep.
So now we are still at the topic of quality, safety, and environment. So the first question I'm gonna ask is, how does your company manage the waste or emissions created during the production?
Okay. Okay. For waste, control waste. Okay, our waste only except for domestic waste. Other waste are treated as scheduled waste. Okay, scheduled waste is whereby a third party vendor will collect from our side to dispose. So this scheduled waste, okay, we have a waste management procedure. Okay, it's according to the waste management procedure. It's written there what type of waste. Okay, you have different type of waste. So because some will be your product waste, some will be your packaging waste. Okay, some will be like whatever your cleaning waste. When you do process vessel cleaning, all these waste, coagulants, all these are treated as scheduled waste. We have our own effluent treatment system. Okay, and we have our own effluent treatment system department where we have 2 technicians working there. So it's their duty to collect all this. I mean, from each production plant, they will every day they will transfer all the scheduled waste into the scheduled waste warehouse. It's a proper warehouse, and we have a limit from DOE, Department of Environment. You have a limit. How many days can you keep this waste? If I'm not mistaken, it's about 180 days. Okay, you only can keep, because whenever you transfer this schedule waste into the schedule waste warehouse, you have to write the date on the label. Each packaging have its own label, and you have to write the date when you transfer. So it cannot go more days to keep there. You need a vendor, licensed third party vendor. So in Keluang side, we have like 2 registered third party vendor lah. Okay, who are like Quality Alam and also 5E. So they will come and collect every week. And the schedule waste is properly managed with this requirement, 180 days or 60 metric ton. You cannot keep more than 60 metric ton also, and you cannot keep more than 180 days. So this is how we handle. We have our own department to manage the schedule waste. So that and also for the emissions, we have environmental management procedure. So in this environmental management procedure, you have all this monitoring requirement. So you have noise monitoring, you have emission monitoring, you have chemical monitoring. So some are quarterly, some are once a year, okay, some are like twice a year. So we follow according to that quality environmental management procedure. Everything is written in the procedure. Okay, so that's how we control emission now. Okay.
Thank you, Sir Divakaran, on explaining on that question. It was very clear. Now moving on to our final topic about the interview session, which is industry outlook and future skills. So for the first question is, which industries in Malaysia rely most on your products? Maybe like in the medical field or the automotive field, or maybe even the agricultural field. And the second question is, what specific skills should engineering students like us learn? What do you think is a must learn before we are ready for future factories?
Yeah. Okay, the first one, if you talk about industry wide lah, because as I say, polymer dispersion is widely used in construction, okay, in coatings, and also in adhesive solution. So if you talk about coatings, yes, paint manufacturer will look for us. So, you know, they need the base product. Paint manufacturer, they just take polymer dispersion and then they just mix with mill base and then they just add on some color and they become their paint, you know. It's very simple. So paint manufacturing is not difficult. So paint manufacturers rely on us. Adhesive producers like glue, like tech bonds, they all rely on us. And construction like cement work, you know, the sealant producers like Sika, okay, they rely on us. If you talk about plastics, plastics are a lot. Like I told you just now that the lining for hard plastics is widely used currently. Even I think now PPF, car wrapping. So all that are polymer emulsions. So the demand for that product is always there, and it only about competition. So demand is high, so you have a lot of competition also. So it's not only Synthomer producing polymer dispersion. Many giant companies are producing, like BASF, you know, like Newplex. So we have a lot of competition lah in the industry. Okay. So to answer your final question, normally from my experience lah, I see, yes, your foundation is your engineering degree, correct? But apart from that, what you guys should do is like you go for like competency certificates. Okay, competency like you go for Six Sigma. Okay, you don't wait. Like Six Sigma, you have like white belt, yellow belt. You do all the low belts first. Okay, before once you enter to a work life, then you can do your green belt and black belt. Okay, all that the lower level one you try to do by the time you finish your studies lah. Six Sigma is very important now for especially for future engineers. Okay, and you can go for GMP, good manufacturing practice, competency. All these are advantage that you guys will have for as a future engineer. Okay.
Thank you very much, Sir Diwakaran. It was a very clear explanation. Now I shall pass the mic back to Mr. Loa, my teammate.
So Lua going to make the wrap.
Yep, I'm gonna wrap it all up. So, first of all, thank you for answering all the questions, sir. So, and that actually brings us to the end of the questions, the end of the meetings. So, Mr. Divakaran, on behalf of the team, I want to say a huge thank you, and the insight that you shared, especially with the third question, where you even gave us the slides and explained to us in a very detailed way, were incredibly helpful, and it will strengthen our final report. And we know that you are busy, so we won't keep you any longer. Thank you again for your time, and have a great week ahead. Goodbye, Mr. Divakaran.
Okay, it's been a pleasure. And if you need any other thing, just text me. I can provide you any any other things to input in your report. And good luck to your guys. Okay, graduate in flying colors. Okay,
Thank you, sir.
bye. Good night.
Thank you.
Thank
Bye.
you, sir.
Good night.
Bye. Good night.